right, guys, so we're going to go on and finish up the note sheet from Tuesday, and that will actually wrap up Chapter 7. So this here is the problem that we left off on. So we finished the one before this here. This one here. So we finished solving this one here on Tuesday. So we're going to start off with this one here today. All right, guys, let's put the Chromebooks away for now. Now, whenever we solve these, 4x, x minus 1 and 2, the first thing we need to do is factor any of the denominators that are factorable. So if we can factor the denominator, we need to do that. Now, looking at these three here, well, the one that will not factor is the x plus 3, because it's already in simplest form, because the degree is 1, and there's not a greatest common factor between the two terms. But the x squared minus 9 is factorable. And it would be x plus 3 and x minus 3. Because x squared minus 9 is the difference of perfect squares, and it factors to x plus 3 and x minus 3. So at least have something here. Now the middle one, the x squared minus 6x minus 9 is factorable. Because the 9 is positive, yes, they'd be the same and they'd both be minus. The factors of x squared would be x and x. And the factors of 9 would be 3 and 3. So we needed to factor the three denominators for one to be able to figure out what the restrictions are. Because the restrictions tell us what values of x we cannot have as solutions. And one of the restrictions is 3 and negative 3. Because if x is 3, positive 3, well, these spots here where x is negative 3, we would get 0 in the denominator. Because 3 minus 3 would give us 0. And if x were negative 3, well, where x plus 3 and x plus 3 here, these two here would become 0. We cannot have 0 in the denominator. So, for this here, we cannot have a solution or a value of x where x is 3 or negative 3. If we do get a solution where x is 3 or negative 3, we know it does not work. It would be an extraneous solution. So that's part of the reason we need to factor the denominator so we can see that there. The other part is when we solve this here, we want to multiply each of these terms by something so that the denominators cancel out completely. Well, for this one here, we would use x plus 3. So we're going to definitely multiply all of them by an x plus 3. And an x minus 3. Yes. Anything else? Yes. We would need a second x minus 3. Because when we look at the middle one, the denominator is x minus 3 and, so we have it twice, so we'll need it twice.
So you basically have to have everything.
And whenever we look at it, we look to see how many times it occurs in each denominator. So in any of the denominators, an x plus 3 occurs once. There are two places where we do have an x plus 3, but because in any of these here it only occurs once, we only need it once. But in the middle, since x minus 3 occurs twice, we need it twice. And for the other ones, in the first one, the x plus 3 and x plus 3 would cancel. X minus 3 and x minus 3 would cancel. Here the two x minus 3's cancel with the two x minus 3's. And the last one here, x plus 3 and x plus 3 cancel. And let's see what we're left with. In the first one, we're left with 4x times, well, the only thing left over is x minus 3 is equal to x minus 1 times, well, x plus 3 plus 2 times, what do we have left over here? X minus 3 and x minus 3, yes? Well, where did we get the x minus 3 and x minus 3 from?
X squared
Minus 6x plus 9, yes? So I could rewrite this as x minus 3 times x minus 3. And when we multiply together, we would get back to x squared minus 6x plus 9, because that's where I got those two from. If we'd have wrote them together, wrote them out as x minus 3 and x minus 3, and multiplied, we would have actually gotten back to x squared minus 6x plus 9. So writing it that way just kind of skips a step in actually solving. We don't have to actually multiply that one back out. Any questions on how we got to this here? Now we just need to distribute and solve. So on the left-hand side, we're going to multiply through by our 4x. So 4x times x would be 4x squared. 4x times negative 3 would be negative 12x is equal to. Here, the middle one, well, we didn't have the x minus 1 times x plus 3 occur anywhere, so we do need to distribute this out. So I have x times x is x squared. X times 3 is going to be plus 3x. We'll do the same thing with the negative 1. Negative 1 times x would be negative x. And negative 1 times 3 is negative 3. Plus, here we're going to distribute the 2. 2 times x squared is 2x squared. Minus 12x plus 18. Any questions on how we got to this point here? Now, at this point, we can combine like terms. Well, 4x squared minus 12x, there aren't any like terms between those two. But on the other side, we do have x squared and 2x squared, and if we combine those, we get 3x squared. Our next one are the x's. Well, 3x minus x would be 2x, and 2x minus 12x would be negative 10x. And last but not least, we have negative 3 plus 18 plus 15. Yes. So we've simplified and combined like terms on either side. Well, we do have 2x squared terms. We have 4x squared and 3x squared. So that means that we do need to get this equal to 0. So what do we need to do first in getting this equal to 0? Yeah, we can subtract 3x squared from both sides. And if we subtract 3x squared from both sides, well, 3x squared minus 3x squared would be 0. 4x squared minus 3x squared is going to give us x squared minus 12x is equal to 10x plus 15. We can add 10x to both sides, because we do need everything on the same side, and negative 10x plus 10x would be 0. On the other side, we're going to have x squared minus is equal to, so last but not least, we need to minus 15 from both sides, which will finally get everything on the same side of the equal sign. X squared minus 2x minus 15 is equal to 0. So we had to move everything onto the same side. And doing it this way is helpful because it does give us an x squared term that is positive. So it makes it a little bit easier to work with if we're going to factor. Now, if we factor this here, our two sets of parentheses with three spaces, well, the 15 is negative, so our signs would be opposite. One's positive and one's going to be negative. Now, the factors of x squared are x and x. And the factors of 15 are 1 and 15 or 3 and 5. Which one do we want to use? 3 and 5. And which one would be positive? And the 5 would be negative, yes. And if we check this, we would get a -2 for the middle term. Any questions on how we got to this point here and how we got this factored? Now at this point here, we do have two things multiplied together to equal 0, so one of these must be 0. Either x plus 3 is 0 or x minus 5 is equal to 0. One of these have to be 0. So for x plus 3 is equal to 0, well, we can subtract 3, telling us x is equal to -3. Here we would add 5, telling us x is equal to 5. But most likely for these two here, once we got it factored, I think some of y'all saw what the values were going to be anyways, yes? Because it's the same thing as what we did for the restrictions. And actually, speaking of the restrictions, -3 and 3, yes? One of our restrictions show up. So x equals -3 does not work for this one here. So our only solution for this problem is that x is equal to 5. And that's our solution. Any questions on this here? And that's all we have to do for these here. Are you ready for the next one? Now again, with these here, we need to factor the denominators if we're able to factor them. And x minus 2 and x plus 2 will not factor, mainly because there's not a common factor between x and 2, and the degree is 1, so most likely those are as simplified as they get. Yes. Now the x squared minus 4 is a difference of perfect squares, which would factor to x plus 2 and x minus 2, or x minus 2 and x plus 2. The order of it really doesn't matter. But again, we're factoring this here to 1, be able to see what the restrictions are. What values of x are going to make the denominator be 0? Yes. And for this here, it'd be 2 and -2. Because for the x plus 2, it'd be -2. -2 plus 2 would give us 0. And for the x minus 2, well, it would be 2, because 2 minus 2 would also give us 0. Any questions on this here? Now, what do we need to multiply each one of these by? X plus 2 and x minus 2. And we're doing this to simplify the denominators out. And this step here where we're multiplying by this common denominator is actually very useful, especially if you're coming across an equation. They ask you to solve a quadratic equation that has fractions or decimals in it on the ACT. If you know a number that would actually make them whole numbers where you don't have the fractions or decimals, multiply it, because that's essentially what we're doing here. We're eliminating all the fractions out of the equation by multiplying by this least common denominator. We're multiplying it by something that will make all the fractions go away. It works just the same as if we had whole numbers without the variables. Because when we do this here, the x minus 2 and x minus 2 would cancel. Here, the x plus 2 and x plus 2 would cancel. And lastly, the x minus 2 and x plus 2 will cancel out with the x minus 2 and x plus 2. And what we're left with is 9 times x plus 2 plus 6x times x minus 2 is equal to, well, 9x squared. Because for the last one, the denominators canceled out completely. Well, the next thing we can do is distribute. Here we're going to multiply through with the 9. So 9 times x is 9x plus 18. Then we'll distribute through with the 6x. Well, 6x times x is 6x squared minus 12x is equal to 9x squared. Yes, I would do that, but I would want to combine like terms first so that we do have it written in a nicer way. Now, we are going to minus the 9x squared over, but let's rearrange this and combine like terms. The 6x squared on the left-hand side doesn't have any like terms, so it stays 6x squared. But the 9x and negative 12x give us a negative 3x plus 18 is equal to 9x squared. So now that we have the like terms kind of all combined and in a nicer way, when we do the subtraction of 9x squared to get this equal to 0, it'll be a little bit easier to see how this works than what we have. Because at this point here we have negative 3x squared minus 3x plus 18 is equal to 0. Any questions on how we got to this point here? Well, we need to find the solutions for this, yes? So we can solve it by factoring. Well, if we're going to factor this, the first thing I would do is pull out a greatest common factor. Yes. I would take out something a little more than just the 3. I would also take out the negative. Because when we factored, all the times we factored so far, the sign in front of the x squared has always been what? Positive, yes? And if we take out the negative 3, it'd make it positive because we'd have a positive x squared. The negative 3x is going to become plus x minus 6 is equal to 0. So taking out the 3 and the negative left us with our x squared plus x minus 6. Okay, that's a little bit easier to work with instead of having negative x squared minus x plus 6. Because if we did it this way with the negative x squared, our factors of x squared, one would have to be negative x and one would have to be x. Right there. Well, here, I have a feeling some of you all have already finished factoring this. Well, since the 6 is negative, we know the signs are going to be opposite. The factors of x squared are x and x, and the factors of 6 that we want are 3 and 2, or 2 and 3. Which one would be positive? The 3, because we want the middle x term to be positive. And if we check this, x times negative 2 would be negative 2x, and 3 times x would be plus 3x, which does give us a positive x. Well, We do have two things multiplied together to equal 0, yes? So one of them must be 0. So either x plus 3 is equal to 0, or x minus 2 is equal to 0. Well, for the x plus 3, we can subtract 3 from both sides, telling us x is equal to -3. For the x plus 2, we can add 2 to both sides, telling us x is equal to 2. But what were our restrictions? 2 and -2. Did we get one of those? So the actual solution for this here is -3. Did we have another way to solve quadratics? We could factor them, or not factor them, but we can actually graph them. And it's been a while since we've done this, but the quadratic we got once we factored multiplied everything out and got it to the same side was -3 x squared plus 3x, or not plus 3x, it was minus 3x plus 18. Graph. So there is two places that it crosses at the x-axis, yes? We already know what they are. -3 and 2. So if it is a quadratic that has whole number solutions, we could actually graph it to be able to figure out what it is. Mind if I borrow this for a second? I'll get it right back. Now, it is possible to do this, but it is a little tricky, because the last thing we solved was what? Alpha y equals, enter, 9 over x minus 2 plus 6x alpha y equals, enter, over x plus 2. Alpha y equals, enter, 9x squared over x squared minus 4. Because what we could do with the graphing calculator is actually tell it to graph these two. Graph the two functions. And what are we saying? We're wanting to see where they are what? Equal, yes? Where they have the same value. So if we look at the table, we can look through all the y values and see where are they the exact same. Well, at 2, we have an error. Because as we already said, 2 is a restriction. It causes the denominator to be 0. So we don't have a value at 2 or -2. But at -3, the y values are both 81/5. So it's telling me that when x is 3, the y values are the same. It's going to be equal. So the solution for this here would be -3. So we can actually graph them and see where do they cross, where do they intersect. And that can help us find it. As long as the solution, the value of x, is a whole number. Because if it's a fraction, we have to do a little bit more work to try to get there. Any other questions on this here? We're going to look at one last one. We'll look at this one here. There are two left, but we'll look at this one here. Now, can we factor one of the denominators? Well, yes, the x squared minus 1 is factorable. So we won't do anything to the 7 over x minus 1. We have 5. Now, how will x squared minus 1 factor? X plus 1 and x minus 1. So x cannot be negative or positive 1, yes? So it's another way we can write negative positive as well. Plus or minus 1, yes? Because we can still do negative 1 comma 1, and that'd be the same thing. Now this also tells us what we can multiply everything by to get the fractions to simplify. So we can say x plus 1 times x minus 1 plus 1 times x minus 1 and x plus 1 times x minus 1. Now let's see what simplifies. In the first one, we would have the x minus 1 canceling with the x minus 1. With the 5, does anything cancel? Well, no. Is there a denominator? Well, no. Since there's not a denominator, there's nothing that'll simplify out. And in the last one, the x minus 1 and x plus 1 will cancel with the x minus 1 and x plus 1. And what that leaves us with is 7 times x plus 1 minus 5 times x minus 1 and x plus 1 are going to multiply together to give us x squared minus 1. Because that's actually where we got the x plus 1 and x minus 1 is from the denominator that was x squared minus 1. So we can put them back together. Is equal to 6. Because luckily for the other side, the entire denominator simplified. Well, at this point here, we just need to distribute and get it equal to 0. So for the first one here, we can distribute the 7. Well, 7 times x is 7x. And 7 times 1 is going to give us plus minus negative 5 times x squared would give us negative 5 x squared. And negative 5 times negative 1 is going to be plus 5 is equal to 6. Now at this point here, it would be helpful to combine like terms. Well, negative 5x squared does not have any other like terms. Plus 7x, because the 7x does not have any like terms. But the 7 and 5 do add together to be 12 is equal to 6. Minus 6 from both sides. And this here will tell us that we have negative 5x squared plus 7x plus 6 is equal to 0. Now we can't graph this, and if we graphed it, it would give us one whole number solution and one fractional solution. But this is factorable. But personally, there is a greatest common factor I would pull out. The negative. I would pull out the negative 1. Because it's going to make this a lot easier to work with. If we pull it out, we'll have positive 5x squared minus 7x minus 6. Negative. 2 sets of parentheses with 3 spaces. Now, since the 6 is negative, our signs are going to be opposite. One's going to be positive, one is going to be negative. Now, the factors of x squared are x and x. Now, the factors of 5 are, well, 5 and 1, 1 and 5. Where do we want to put the 5? Either one. So I just put it in the first one. That's just how I personally do it. I just throw it in there because, again, we can always check it. And if it didn't work out, we can always rearrange it. Now, the factors of 6 are 1 and 6 or 2 and 3. Which one do we want to try first? 2 and 3. Which one do we want to put first? 2 and the 3. Now, we can check it to make sure we did get the correct setup. 5x times negative 3 would be negative 15x. 2 times x is going to be plus 2x, which would give us a negative 13x. So that's not quite what we wanted. So, hold on. Let's try flipping the 2 and 3. So put the 3 first and the 2 second. Now if we check this here, 5 times negative 2, 5x times negative 2 would be negative 10x. 3 times x is going to be plus 3x, which would give us a negative. Okay, that's what we wanted. And now we just need to set both of these equal to 0 and solve. So we'd have 5x plus 3 is equal to 0, and x minus 2 is equal to 0. Well, for the 5x plus 3, the first thing we can do is subtract 3 from both sides, which will tell us that 5x is equal to negative 3. And last but not least, we can divide both sides by 5, telling us x is equal to negative 3/5. And really solving this is just going the opposite direction of if we plugged a number in. Because if I plugged a number in for x, we would first multiply by 5 and then add 3. So we're kind of doing the opposite, subtracting 3 and then dividing by 5. So we get negative 3/5. And for the other one, we add 2, telling us x is 2. But our restrictions were 2 and negative 2, yes? Or no 1 and negative 1. 1 and negative 1. So are either one of these are restrictions? No, so they both work. And that's it. That's all we're doing in this here. Any questions on any of these here? Now, I did this one in the other 2 hours. The only thing that really this adds is that, well, when we go and solve it, x ends up being 3 plus or minus 2 square root of 3 over 3. And this still works. So for these problems here, we are not restricted or contained on having whole number solutions. We can have irrational solutions that work just fine. Because it ends up being the restrictions for this are 1, negative 1, and 2. But that's not any of those there. So we can have irrational numbers as a part of our answer. And still works just fine. But a lot of the times, especially when we cover this and go over this, it's easier to work with them if they have whole number solutions than if they have solutions like this here. But that is the end of chapter 7. So this here is your last assignment on page 400, problems 23 through 26, 29, and 30. So you do have those there. Also, as a part of, because Winter Olympics started, I did put up a math trivia question that's loosely connected to the Olympics. Every 4 years, yes. Because the Winter Olympics are every 4 years between each Winter Olympics. Summer Olympics are every 4 years between each Summer Olympics. And the amount of time between the winter and summer is, I don't know, 2. Because, I mean, the last Summer Olympics was supposed to be in 2020. 2022 is the winter. So in 2 years will be the summer, 2 years the winter.